Welcome to Giant Prehistoric Monsters, where we dive deep into history to uncover the secrets of the largest marine reptiles. When most people imagine the largest animals to ever walk or swim, they usually picture massive dinosaurs or modern whales. However, long before mammals took over the seas, a specific marine reptile grew to truly immense and terrifying proportions. This creature reached a size that defies logic, pushing the absolute biological limits of what a reptile could actually become. The name of this colossal beast was Shastasaurus, a titan that ruled the waves long before the famous Jurassic period. Shastasaurus lived during the late Triassic period, more than 200 million years ago, in a world vastly different today. This was a time when the Earth's oceans were slowly recovering from one of the most devastating mass extinctions ever. Despite these harsh conditions, life found a way to rebound, creating giants that would dominate the ancient waterways for millions. Fossil evidence discovered by paleontologists suggests that Shastasaurus reached incredible lengths of up to 21 meters from snout to tail. This incredible length means it rivaled, or even exceeded the size of many modern whales that swim in our oceans. Imagine a creature as long as a bowling lane or a semi-truck, gliding silently through the dark prehistoric waters. Unlike most giant marine predators we know, Shastasaurus was not built for violence or tearing apart large prey with sharp teeth. It belonged to a successful group of marine reptiles called ichthyosaurs, animals that evolved streamlined bodies very similar to modern dolphins. These creatures were reptiles, yet they had adapted perfectly to life entirely underwater, giving birth to live young in the sea. But Shastasaurus stood apart from its smaller relatives in a remarkable way, possessing a body plan that was truly unique. While other ichthyosaurs were swift hunters, this giant had a different strategy that allowed it to grow to massive sizes. It possessed an extremely reduced jaw structure, with no large teeth designed for tearing flesh or crushing heavy bone and shell. This unusual anatomy suggests to scientists that Shastasaurus did not hunt large prey like other marine reptiles of its time. Instead, researchers believe it fed primarily on soft-bodied organisms such as squid and small fish found in the deep. It likely used a method known as suction feeding, rapidly opening its mouth to create a vacuum rather than biting. This specialized feeding method allowed it to consume vast quantities of food without needing the heavy weaponry of a predator. To support a body of such immense size, Shastasaurus relied on sheer volume and metabolic efficiency rather than aggressive hunting. Its massive torso allowed it to store significant energy, enabling it to travel long distances through the vast open oceans. This feeding strategy mirrors that of modern baleen whales, which filter enormous amounts of small food without the need for sharp teeth. Shastasaurus lived in a world where oceans were warm, deep, and rich with marine life, providing a perfect feeding ground. The global temperature was higher, and the seas were teeming with cephalopods, which served as the primary fuel for this giant. Its size may have been a direct evolutionary response to an abundance of easily available prey spread across vast distances. Being large allowed it to conserve energy better than smaller animals and avoid almost all predators existing during that time. A creature of 21 meters would have very few natural enemies, allowing it to roam the Triassic seas safely. Despite its enormous size and intimidating silhouette, Shastasaurus was likely a gentle giant of the prehistoric seas, drifting slowly. It moved through the water with deliberate grace, using its 4 flippers to steer while its tail provided propulsion forward. It played a crucial role in shaping marine ecosystems by controlling populations of smaller organisms like squid and schooling fish. By consuming these creatures in bulk, it helped maintain the delicate balance of the food web in the ancient ocean. Imagine the sight of this leviathan, its dark skin blending with the deep water, surrounded by clouds of small prey. However, like many giants of the Triassic period, Shastasaurus did not survive the environmental changes that eventually followed this era. The world is constantly changing, and the specialized lifestyle of Shastasaurus eventually became a disadvantage as the global climate shifted. Shifts in climate, ocean chemistry, and marine food webs eventually led to the disappearance of these magnificent giant ichthyosaurs. As the Triassic period came to a close, the oceans underwent a transformation that made food sources less reliable. By the end of the Triassic period, Shastasaurus vanished from the fossil record, leaving only bones to tell its story. Its extinction marked the end of an era for giant ichthyosaurs, paving the way for other marine predators to rise. Today, its fossils remind us that the largest marine animals were not always fierce predators with rows of sharp teeth. These remains have been found in places like California and China, showing how widespread this species was in ancient times. Sometimes, evolution favors size, efficiency, and balance over brute force, creating creatures that are peaceful yet massively impressive in scale. Shastasaurus stands as one of the most extraordinary examples of how far life can push its limits when conditions allow. It remains one of the largest marine reptiles ever to swim in Earth's oceans, a testament to prehistoric biological diversity. Let us look closer at the anatomy of this beast, specifically the ribcage, which was surprisingly short compared to others. This short ribcage suggests a body shape that was not just long, but also deep, providing stability in the water. The flippers of Shastasaurus were also unique, adapted for maneuvering its massive bulk rather than for high-speed pursuit. Its eyes were large, adapted for seeing in the dim light of the deep ocean where its prey often hid. Vision was likely its primary sense, allowing it to spot shoals of squid from a distance before approaching to feed. The color of Shastasaurus is unknown, but scientists speculate it had countershading to blend in with the dark ocean depths. Dark on top and light on the bottom, this camouflage would help it remain unseen by both prey and predators. We can imagine mothers traveling with their young, navigating the vast prehistoric currents in search of rich feeding grounds. The bond between mother and offspring in ichthyosaurs was likely strong, as they gave birth to live young at sea. These social behaviors are speculative but based on the intelligence and complexity seen in modern marine mammals with similar lifestyles. The legacy of Shastasaurus challenges our perception of what a monster is, showing that size does not equal aggression. In the grand timeline of Earth, Shastasaurus represents a peak in marine reptile evolution that has never been repeated since. While pliosaurs and mosasaurs would come later, none matched the unique combination of size and suction feeding of Shastasaurus. Paleontologists continue to study these fossils, hoping to unlock more secrets about how such a massive creature lived and died. New technology allows us to scan bones and reconstruct its movement, bringing this ancient giant back to life digitally. Through these reconstructions, we can see the elegance of its movement, a slow, rhythmic dance through the ancient Triassic waters. It serves as a reminder of the fragility of life, even for the largest and most successful species on Earth. When the environment changes too rapidly, even the giants fall, leaving behind only stone and mystery for us to find. The story of Shastasaurus is a humbling chapter in the book of life, teaching us about resilience and ultimate extinction. As we explore our modern oceans, we see echoes of Shastasaurus in the whales that filter feed today. Evolution often repeats successful designs, and the niche of the gentle giant filter feeder is one that endures through time. But the reptile version of this niche, the Shastasaurus, remains a singular marvel of the Triassic period's unique ecosystem. We hope this journey into the deep past has given you a new appreciation for these forgotten titans of history. The ocean holds many secrets, and Shastasaurus is just one of the many monsters that once called it their home. Understanding these ancient creatures helps us understand the history of our planet and the incredible power of natural selection. From a small lizard ancestor to a 21-meter giant, the journey of the ichthyosaur is truly magnificent. Shastasaurus will always remain the king of the Triassic seas, a ruler who governed with size rather than sharp teeth. Thank you for joining us on this underwater expedition through time to meet the biggest marine reptile in history. If you enjoyed learning about Shastasaurus, please remember to like and subscribe for more deep dives into prehistoric life. This has been a production of Giant Prehistoric Monsters, exploring the ancient world, one giant creature at a time. Goodbye.